Hello everyone and welcome to Van Tech Corner. In this video, let's install OpenWrt 25 on the Zimaboard2 and check out its performance. The Zimaboard2 is the second generation x86 server from Israel. It is powered by the Intel N150 quad-core CPU and comes with either 8 or 16GB of RAM. For networking, it had two 2.5GB Ethernet ports and a PCIe X4 slot to add more Ethernet adapters, which is perfect for networking applications. My Zimaboard2 had 16GB of RAM, and I know it is overkill for OpenWrt. Anyway, since I already got the device on hand, let's give it a try. First of all, let's go to downloads.openwrt.org to download the firmware. As the Zimaboard2 only supports UEFI, we need the OpenWrt/EFI firmware in order to boot. As usual, I use root first to write the firmware to the USB write. Of course, we can install the firmware to the internal eMMC storage. I prefer not touching it as I may need to go back to ZimaOS in the future. Alright, the USB write is ready. Let's insert it to the Zimaboard2 and boot. I will also connect a USB capture card to see what is going on the screen. I will leave the Ethernet ports not connected as we don't know which is which, but no worry, we will find out later. The booting process is quite fast. OpenWrt 25 is up and running on the Zimaboard2. Let's set up the root password by passwd command. Now I will connect the PC to the Ethernet port on the right side of the Zimaboard2. Very well, there are logs on the screen. Ethernet 0s enter forwarding state. We know that Ethernet 0s is the LAN port and it is on the right side of the Zimaboard2. So the other port must be one port. Let's visit 192.168.1.1 to have the LuCI Tour. Here we are. This is OpenWrt 25 running on Israel technology Zimaboard2. The CPU is Intel N150 and OpenWRTs come with kernel version 6.12.74. We have 16GB of RAM and just 86.44 of storage since I don't extend the partition space. Now I will connect the media converter to the Zimaboard2 one port and set up internet connection using PPPoE. My ISP requires VLAN 35 and it is quite easy to set it up. Very good, there is public IPv4 and IPv6 address. Let's run the speed test. The test is done. The download speed is 1070 Mbps and the upload speed is 847 Mbps. Due to the internet plan's limitations, I'm not able to get 2.5GB Ethernet throughput, but I do believe the Zimaboard2 can handle that easily. We will verify that later. Let's run the test again with the CPU usage overview. This time, we can see that the download speed increased a lot. The CPU usage is at around 25% when the download speed reaches 1800 Mbps. Now, let's check out the WAN-to-LAN throughput. The Zimaboard2 WAN IP is 172.16.10.65 and I have a test server as 172.16.10.11a. For this test, packet steering is enabled with 128 steering flows. Shortwave offloading is disabled as it won't work on this build. Very well, the download speed reached 2461 Mbps and the CPU idle is at 77%, which means 23% CPU load. Multi-core handling is good as we can see the load shared across 4 cores of the CPU. For upload, the speed is 2468 Mbps and the maximum CPU load is 25% as can be seen from the top command. The result is identical in the second test. We have 2469 Mbps download and 2469 Mbps upload. Let's see how it does with iPub3. With 4 streams running in normal direction or upload, the iPub3 throughput is 2.37 gigabit per second. During the test, the CPU usage is around 25%. Running the test in reverse or download, the recorded speed is also 2.37 gigabit per second. CPU usage increased a little bit to roughly 25%. Changing the number of streams to A, the iPub3 throughput is still at 2.37 gigabit per second, which is the highest throughput recorded in Windows with default jumbo frame. Now, we will see the Wireguard throughputs of the Zimaboard2 with the Intel N150 CPU. Here, I have a Wireguard server running on the one side with IP address 172.16.10.150. All the settings is default using the Wireguard installation script from NYR. In order to see the actual CPU usage and the interface bandwidth, I have top command on top and bmon at the bottom. The download speed is reaching 1900 Mbps and the CPU usage increased to 60%. We can also see the same throughput on bmon console. For upload, the speed is higher, it is up to 2000 Mbps. CPU usage is around 55%. The test completed with 1891 Mbps download and 2014 Mbps upload. Now, I will change the top command to htop in order to see the CPU load of 4 single core. Very well, we are reaching 2000 Mbps Wireguard throughput and the CPU load is shared across 4 cores of the CPU. Raiden. I have run the test several times and the Wireguard throughput remains stable at 1900 Mbps. You may wish to know the power consumptions of the Zimaboard2 when running OpenWrt. We will check it out now. The Intel quad-core N510 on the Zimaboard2 consumes very little power. From my observation, the power consumption is more or less the same with the N5105 that I tested previously. During either with 2.5 gigabit Ethernet port connected, the power consumption is 7.1 watt. It's worth to mention that in this case I have the mini DP ports and USB ports connected. If you are running OpenWrt from the eMMC headset lead, the power consumption may be lower than that. Downloaded at 2200 Mbps, 25% CPU load, the power consumption reaches 10 watt. The same power throughput is recorded during upload tests at around 2400 Mbps. Alright, so that will be all for this video. If you wish to know more about the ZimaBoard2, do check out my review with the stock ZimaOS. Link is available in the video description. Thanks for watching and see you all in the next video. Bye bye.